Hello, dear friends. Welcome back to my YouTube channel. Today, we are going to see something quite interesting: a DC to DC block converter. Fully right, you've been seeing it in other videos or books, or maybe it could be your first time seeing it. But today, we are simulating it in an extra software that is called Psim. Psim standing for Power Simulator. Yeah, this actually very good software when it comes to electronic simulation. It goes right into the details. So here is a secret which we are going to be looking at. We we put this in place to step down the voltage from the input. We set this maybe to 100 volt. For your system it could be 40 volt depending on what you are dealing with. Then we define a duty cycle that's going to give us setting the voltage either half, one quarter or three quarters of the input voltage. So without talking more, let's proceed into connecting the various components of the circuit. After all this about it, we will explain the circuit as a whole. So here's our power supply. Then for the sake of safetyness, usually in physical safety, normally we have to have need to put in place input capacitor to avoid spikes at the level of the input. So that's how the case in the software. And here is our switch. I can set green of the system. This switch will be controlled by burst generator. Burst generator. Burst generator. These components usually are chips for generator. High frequency pulse modulation for switching was set through a gate driver. Okay, once those are connected, now we put in place a diode. We're going to talk about the use of this diode. Let's place it over here. We have an inductor. I'll call it the muscle of the circuit. Yeah. This is the one actually doing a lot of work. Strength. Actually discharging, charging really fast. Then finally, most crucial component, output capacitor for filtering the voltage output. That's making it smooth. Then we proceed to put in place our load. That's the resistor. Okay, let's get to connect everything. This over here, this over here, this over here. Okay, now we connect our ground. That is it. Our circuit is complete. Now let's explain how it works. As I mentioned already, we have an N-channel MOSFET here, which is actually the brain of the system. Brain of the system in the sense that it's switching on and off. It actually gives the amount of voltage sent to the other side of the circuit that has been outputted to the inductor, capacitor, and even our load. So during the on process, during the on process of this, during the on process of this N-channel MOSFET, we have voltage flowing directly from the input to the inductor. To the inductor. This inductor right now stores energy during the on time. During the on time of the N-channel MOSFET. This line is just going to the right hand side. So during the on time, the inductor stores energy. And now you see that during this on time, voltage is not able to flow across this diode because it is going to be the reverse. We have forward bias and it's going to be the reverse bias. So no flow is going to occur there because if it actually gets to flow from there, it will go back to our power supply. That is a short circuit. So why then are we putting it there? We are going to see it next. Now, during the off time of this MOSFET, that is after the inductor has stored a little amount of energy. After the inductor has stored a little amount of energy, Now the inductor here is the one that has the energy and has to discharge it out. It actually discharges it by flowing it through this output capacitor. So the discharging process passes through this output capacitor, which supplies the load and resistor here. That's what the keys are resistor. It could be a motor, a head, so as it flows through this capacitor, it's trying out the importance of the diode. It puts the circuit in a closed loop. The inductor, the diode, sorry, is going to be forward bias. Forward bias. Hence, our capacitor is going to be charged. Our load actually be supplied. So that said, that is everything we need to see. We are going to put in some values here based on the system which I worked on once. Solar charge controller for the 70 micro farad 35 kilowatt pipes. So there's no price information. And here, since a bulk converter, we are not going to do the high voltage in our circuit. And our advice you guys actually subscribe to this channel because I've been doing a lot of videos where we are for components. Every time I take and share with you guys documents in which I've been able to cite components for the system I implemented. Yeah, as an engineering student. So 220 microfarad for that. Now my system I use 68 microhenry. So for the sizes of this component, basically there are a lot of books on it. Now this is what actually causes a channel MOSFET to switch. Here you are able to set a frequency. The higher the frequency, the more efficient the system is going to be. And in setting this frequency, you need to make sure the inductor is selected. Can switch that can store and discharge, store and discharge, store and discharge energy at that rate. Else it's not going to work. Yeah, if you're going to this step. Now here is a point where we set our duty cycle 0 to 180. 0 to 360 is a full clock. So 180 now will be 0.5 duty cycle. That's 50%. So you have a way of solution with 50% duty cycle. 50,000. Right. From there now we set simulation time to 1 second. Simulation time to 1 second. Okay, then we run our simulation. So you say okay. Oh, my bad. We didn't place a voltmeter on the output. So let's place a voltmeter here in the level of this phase. Escape. Let's place a voltmeter. Then we run our simulation. Okay, as you said, the duty cycle to 0.5, that's 50%. Our input voltage being 100 volt. So 50% of 100 volt, that should be something around 50 volt. Yeah, as you can see, the output is 24060. That is 5 extra to 1. That is actually 50 volt. 50 volt will require for a system. Okay, now if we get to zoom this graph result, you are going to see the switching process of the N-channel MOSFET. Yeah. Each time it's switching on and off, on and off, on and off. So there's no time in which the inductor voltage is going to be zero or the inductor energy is going to be zero, because it immediately discharges through the capacitor or MOSFET comes back to the on, charge it, and the process will repeat itself continuously. So thanks for watching. Like I mentioned already, make sure you subscribe and on your notification bell to receive updates on new electronic circuit which we are going to see video Psim. This is a new beginning for us to then join the future. See you guys